Okay, it's 3 o'clock. Shall we start? Um, does anyone do not speak fluent Portuguese? Okay. Security, we have a problem here. We got someone not speaking. Just kidding. So, this will be a talk about aspect-oriented programming, and the reason this is about Android is mainly because I've been working with Android for the last 2 years. So it's what I'm comfortable right now. And first, why are we using aspect-oriented with Android? When we started with Android programming, when we started looking at the code and the API and the documentation, quite frankly, I didn't like it. And so does the Odyssey start. So at the beginning, when I started looking at the code and the documentation, we thought, well, this really sucks. I must be missing something. Then came Hangar. We had perfectly good JDBC on the server side. Why did they have to reinvent content providers, for example? Then came bargaining. We started searching in the web for APIs and frameworks that we could use, but none was available. We even started trying to patch something to work with that, but just Android, Google code. Then there was a brief phase of depression when we thought maybe we just should stick to using PhoneGap or something like that. And then, well, that's what we are paid to do. It's to write code for Android, so let's start coding. And as they say, real men don't hit honey, they chew bees, so we rolled up our sleeves and started hacking away. But in our search, basically, we found out that aspect-oriented programming helped a lot. So what is aspect-oriented programming? As someone said once, if a language doesn't make you think any different, it's not a language that it's worth learning. And so aspect-oriented programming and aspect-J does make you start to think things a little bit different. And I think it's quite worth the effort. So as an example, let's suppose that this is your typical classes, and on the gray color, it's what you really want to do. It's your business code, if you want to call it that way. But somehow, in order to support what you want to do, maybe you want to have a security check, make sure that the user is logged in, that this cookie is still valid or whatever. Maybe you want to have a logging function that says user did this or did that, and maybe you want to have some kind of persistence. For example, if you fetch something from the network, you don't want to keep fetching it again, maybe you want to cache it. And then you can cache it in a file, in a database, or whatever. But this leads to something that's called code tangling. Basically, the thing you want to do is this great thing, and your code gets tangled with other stuff. And code scattering, in which maybe the bulk of the supporting code is in another class, but you have to scatter it around other classes to make it work. And the promise of aspect-oriented programming is that you can write all your business code, what you really want to do, in a simple way, and having the other stuff that supports your code in other places. And through a process called weaving, the thing gets connected again. So another way to think of it is that you have concerns. That's what we call cross-cutting concerns. So your main concern is your business logic, because if you have your database in order and your security in order and everything else, you still don't have a product. So there's no point in having all the other stuff if you don't have your business logic. So you can think of this as having your business logic and having other orthogonal concerns like transaction manager, security, maybe error logging, and whatsoever. And through the process of weaving, your code gets mixed up again to a linear space, your bytecode, if you want to see it that way. So one way to think of aspects, it's like theming. Well, in theming, you don't really care when you're programming an app with the GUI. You don't care if the menu options are in the title bar or are in the top like Mac and Unity does, which I think it sucks, but some people like it. So you don't care. People that are programming the stuff, that they don't care where the things get. As long as there's an option to press that and your code works, that's okay. So you can think about AOP as like applying themes. So I'll introduce just a few concepts and picking up on that theming metaphor. For example, if you have done any web development, in the old days you used to mix HTML with tables and fonts and display. Nowadays everybody does your content in HTML and they put your cascading style sheets to control how the thing gets displayed. So if you're coming from that background, it's useful to think of this as a metaphor in which the point cut is your cascading style sheet selector, and the join points are all the classes get matched. And the advice is just your cascading style sheet. What gets applied to your paragraphs, divs, whatever. And the aspect is like your cascading style sheets. If you're coming from a database administration background, you can think of the point cut as your SQL query and your join points as the rows in the database that get matched. And the advice like triggers in the database that happen when something gets inserted in the database, for example. And the aspect is the thing where you keep all your code. Or if you're coming from a shell background, you can think of the point cut as your regular expression and the join points as the things that get matched. So you can think of these concepts like this. Sorry. So how does Aspect-J implement aspect-oriented programming? Well, three main ways. The source code weaving, binary weaving, and load time weaving. Basically, in Android, we use source code weaving, and that just, what does that mean? It means that you keep your source code for your aspects and your source code for your business code, and the compiler mixes both to produce Java bytecode. In binary weaving, that we haven't used yet, but might have with the new tools, you can compile to a jar all your aspects, and you can compile all your business code, and then the linker mixes the code together, so you can have a final bytecode, which means that you can change the way, if you don't have the source code for something, you can change the way it works, even if you don't have the source code. Probably if you don't have the source code, you're violating some kind of licenses, but it's certainly something that you can do for educational purposes. And then there's the load time weaving, in which you just start the Java machine, virtual machine, and through class loading magic, the code gets mixed. In the Android, I don't think that will ever work. I think I've never tried because you might know that the Android doesn't have a real Java machine, virtual machine. It has a Dalvik virtual machine. So that's really not an option. So how does it work? It's really simple. You, after installing a plugin for the AspectJ, you pick any project, in this case an Android project, you click on configure, convert to AspectJ project, and it's done. That's simple. What does that do? That basically changes this builder. In any regular Java project, you would have here a Java builder. And that changes the Java builder with an AspectJ builder. This is basically just a compiler that understands both Java and aspects. If you work with other Java virtual machine bytecode languages like Scala, you will notice that they also do the same thing. They would change the Java compiler with a Scala compiler that understands both Java and Scala. So you can't have both at the same time. If you need to have that, you can make AspectJ work with things that get compiled in other languages, but you will have to use the binary code weaving that we won't cover. And for Android, there's just a small note that just this detail. It's that when you compile the code, you are using the AspectJ code, but the AspectJ code has a small runtime library, really small, like 60K, that needs to go together with your code. And the regular process somehow doesn't add the library, so we just add it again, and that works. So it's okay. Supposedly I haven't had much time, but with the new tools, that's the release 15 tools, I don't think that's needed, but I haven't had time to work with those yet. But it's really simple. So this will be our case study, really simple. This is your business code, what you really want to do. So this is one of the Codebits API that picks the most awesome talk in these Codebits, which you might guess what it is. And what you want to do with that, it's basically, we have a function here that gets that URL and it returns a string with all the content. You turn it into a JSON object and then you parse it for the description and you set the text of the layout with that description. Just that one thing. That's what you really want to do. The problem, if you have done anything more than an hello world in Android, that you start seeing is that if you call this function here, and this makes a network access, and this takes for some seconds, you're probably going to get an application not responding error. Why? Because like Swing, Android has a single-threaded model, so everything works on one thread. And if you don't want to block the UI on that UI thread, you have to do things that are heavy or that take a long time. You have to do it in a background thread. And should we be worrying about that? In my opinion, we shouldn't. And we will see how to fix that. So, the first thing, just to show you a little bit of code, and we'll see how we can make that work. To start showing a little bit of the code. So you see that an aspect, instead of saying public class something, just says public aspect. and in reality, aspects get compiled to classes. So these are just kind of like classes. And then you see a declare warning. This is something that you want to use. You might want to use if you want to make your code better. What does this do? Basically, this issues a compiler warning if in your code it finds any call to the print stream with any number of arguments that return anything, or a call to Android util log that's not within our own logging framework, because the Android logging framework sucks. So we did our own. Or if there's a call to a throwable print stack trace. Usually when you surround something with a try-catch, the Eclipse usually builds up your code automatically and it inserts a print stack trace. And maybe you don't want that in your code, so this issues a warning. So with this simple example, you could start using an aspect for code improvements. So your coders wouldn't even have to be using aspects. You could use this on cruise control or something like with continuous integration, just to make sure your code complies to the rules you have set. Your coders don't need to be using aspects. So one of the first examples that's really useful, a lot of times you need to just log something, and what ends up happening is that you have to put a log action in each place you want to log. And for example, in our case, when I wanted to see the full stream of what I got from the net, and this is how I do it. So like an aspect, and there's whenever the compiler finds a call to the get URL as string, it does the following. It does something around it, which means before and after. So this is a reserved keyword that just calls what you want to do. So if I'm matching this, the proceed is actually calling this. So I call the proceed and the string gets attributed to the result. And then I log it. So this is just my logging function, where you can see another reserved keyword, this join point cut, which means just the function that got matched. I get its arguments, and then I print also the result. This thing is called the point cut, and you can give it a name. That's what I did here. So I gave it a name, and then I used the name. So this would be the same thing as putting this code here. And when you're logging something, for example, you want to log every time you enter a state of the activity, you can get the name of the method you are trying to match. You do this this way. This line point cut, get signature, short string, and this prints the name like on create, on pause, and whatever. And this works for all activities. So you wouldn't have to write that logging code in every activity you have. You just do this with 3 or 4 lines, and everything in your code gets logged. That's how easy it is. So going back a little, this is our example code. So we wanted to do this on a background thread. And I've used an annotation just to say this should run on a background thread. And the way we do this, we create an aspect that matches everything that's annotated with the background annotation, that returns void in every class, every method with every number of parameters. And basically, this launches a new thread and calls the proceed, which is the method I'm annotating. So, and starts the thread. So just by applying this and annotating a method with the background annotation, I'm making sure that everything, just by annotating with the background annotation, runs in the background. So, if you've done some development, you'll notice something. Okay, so now I don't have to see the code for running things in the background. But there's a problem. If you try to update UI in the background thread, the compiler, the runtime throws an error saying that you can't update the UI in the background thread. So how do we fix this? With another aspect. And this is bordering on inception. So we run an aspect inside an aspect. So basically that's what I'm doing here. There's a method called run on UI thread that takes a runnable and does something on the UI thread. And we do that every time there's a call to any class that extends the view, like text view or some other view, and any method with any number of parameters. And that's within the code that's annotated with the background. So whenever the compiler sees this, it's annotated with the background, so it matches. It's a view, it matches, doesn't return anything. So this would be the same as calling the new thread, and inside the new thread calling the run on U thread of this piece. Okay, so another aspect. Probably, if you're doing something on the background, you want to give some feedback for the user. If something takes a long time, you usually show a progress bar, like you're loading something. And that's something you can do with aspects also. So basically, we write another aspect saying that anything that's annotated with a background thread, with a background annotation, we first set the progress, we call the function, and we set the progress to false afterwards. So when the function starts, it starts the progress bar, and when it finishes, it stops the progress bar. And here I'm showing that aspects can have their own methods. So this is an aspect, and it has this method that's called by an around advice. And also, for that to work, in every class, you will have to, in every class that needed the progress bar, before setting content view, you have to call a special function for that to work. And instead of writing that in every class, you write that with an aspect. So I'm saying, before the set content view of any activity or anything that extends activity is called the request window feature with this keyword, so that the Android knows that it has to reserve space for a progress bar. By now, if you're paying attention, you should have noticed that we are applying all these aspects to the same method. And the order in which we apply those aspects matters, because say, if we apply first the new thread, and we launch something in a new thread, and we do this before, what gets called is you set the progress bar, then you launch a thread, which is really quickly, something starts happening in the background, and you set the progress to false, and you wouldn't see anything showing. So it's important the order in which things happen. So you want to this aspect being closer to the method you're calling, and then in the outside launching a new thread with this inside. And that's what we do in here. So but there's another keyword, that's declare presence. When we are applying aspects to the same join points, and basically I'm saying the order in which they apply, being this one the closest to the method I'm calling. So I apply this first, then the show progress, and then launching the thread. And you can even think of as error handling as another aspect, because your business code is going to the net and fetching something. Dealing with errors sometimes is just another concern that doesn't deal directly what you are trying to do. So in our case, there's a really simple error handling. If we call a function and there's an exception, remember that we are calling this in a thread. Then we just launch a toast saying, sorry, there was a problem. And that's why there was here an error handler. So going back a little bit. Here you can see that you have just written this code, but if you had to write everything for every activity, you'd have to write this inside a try-catch, inside a run-only thread that shows the progress before and after, inside of a new thread. So you'd have this code written all over all our activities that do the same thing. And now you can see that you just need to write this stuff. So there's a lot of things we have covered already. And then it's just an interesting idea. If you're doing tests, for example, maybe you want to simulate that the network gave an error. Instead of changing your code, you can write another aspect. And you can do this. Whenever there's a call to my function that gets something for the net, before there's a call to that, I will throw an exception. So it's really easy just to test. Let's see how this behaves if there's an IO exception, and you don't have to change your code. So you just change it here, and your code stays the same. Now we're really getting interesting. I think it's interesting. If you've having been studying other languages like Scala or Ruby or whatever, crap there's around, you'll notice that they have something called mixins or traits. Basically that means that you can have interfaces with code. In Java you don't have multiple inheritance, so you usually have to make some class implement an interface, and whenever that happens you have to implement the code in that class always. And with aspect-J you can turn around that. Okay. So with aspect-J you can do that. So basically there's a really simple example. If you noticed our case study, I'm using this function which is called find by ID. If you have done anything in Android, you know there's a find view by ID that just returns a generic view, and you have to typecast it to the kind of view you want. So if this is a text view, you would have a cast to text view here. So clearly the Google folks had never heard of generics, and so I decided to implement something that does that. But that would be useful in every class that I use, and not having to extend classes, which is what they usually do. So I implemented that. And this is my function, find by ID, that just finds by ID and typecasts to the generic. That's basically the idea. But the interesting thing is here that I'm having this interface that's just a marker interface. It doesn't really have a code. It's like serializable, for example. And I'm changing the structure of the class. So I'm saying that my launcher class now implements this interface. So I can change the structure of a class. And now I'm saying a really interesting thing. I'm saying that for every, if you notice, this is the same name, for every class that implements this interface, add this method. So basically, I'm giving an implementation to an interface. And now my classes don't have to implement every code, so I just need to say they implement some interface, and automatically they gain all the behavior that would be in a Scala trait or something like that. If you want to make things more like Scala and other classes where you define everything inside one single class, you could write this aspect inside here as a static aspect, and you would have everything in the same place. You wouldn't declare this. And now your classes would just have to say implement better activity, and they would automatically inherit this behavior. And so I've covered a lot of examples, and after a while you start seeing everything that can be solved with aspects, and you might be tempted to think, well, I'm going to use aspects for everything, and that was my case. But we must remember that object-oriented good practices are still useful, and we should use them, and that aspects can improve the code and change the way things happen, so we can concentrate more on what we really want to do, and leave the rest that's not essential to some aspects that you can apply as a theme. So, for example, if you went back to this background, here you can see just that I'm launching a thread. But I could change this aspect to use like a thread puller, for example, and my code wouldn't change a bit. So I can experiment with different themes that I can apply to my code and see what works better. I don't have to, let's see, now I have to change everything in every place, everything again. Here I'm just launching threads. You could be using the awful async tasks that they use, or you could be experimenting with looper and handlers, or you could be using the thread pullers, whatever. You have just to change one class, and every class that implements the background annotation would benefit from that behavior. And so this kind of my philosophy. We went back to the essential, and we just write the code that we really need to do, and everything that's just supporting the code of what we need to do gets cleanly written in another place that you can change afterwards, and you don't have to change anything else. So instead of having to write a pile of code, we just write this, and there's a lot happening here. There's things running in background, there's progress bars running, there's error checking here, there's thoughts happening if there's an error. So you just concentrate on what you want to do and leave everything to the aspects. So these are the resources. This code is fully available and in this GitHub, so you can then download and experiment and change stuff. This is the book I recommend the most. I've read a number of them, and this is clearly for me one of the best books. There's a second edition. I recommend that one. This is the official site of the Aspect-J compiler, and this is the Aspect-J development tool for Eclipse. And since if you are interested in Android, and probably using Eclipse, so this is the one you want to get. This is just my site where I'll post all this stuff. There's nothing there yet. If you have any doubts regarding aspects or Android, one of the best sites is Stack Overflow. People write doubts there, and other people that know better answer that. Even Google authors and coders go there and write their answers, and they support that site. This is a cool guy from the cool site from McMurphy, which is a guy that writes Android books. And for the price of one, I have no affiliation with him, nor do I get anything. But for the price, basically one book, you get 1 year of supplies of like 4 books on Android. So if you're starting, I really recommend that one. I didn't start with that one, but I wish I did. There's all our apps in Sapo. And if you really must, as a last resort, there's the own site for Google Code, which sucks. And you're better off watching the code, pulling the Git and see how they do things, because most of the times the documentation really isn't that good, and you really want to, if you do any serious development, you really want to do and look at the code. And that's it. If you have any questions. Sorry?
What about debug? When you're debugging the live application, the breakpoint, what happens? Does it match well the line source code?
Okay. Okay. So the question is about debugging. Does it manage well when you're trying to debug something? To tell you the truth, I never use a debugger. I'm old school, I use log lines. But yes, it does. I've tested once. My colleague uses that sometimes. And although the code is weaved in, you write stuff in one class in an aspect that's weaved into a single bytecode class. If you have something that throws an exception, you can clearly understand from the stack trace where the error happened, in which line, if it was on an aspect. So this isn't just like some bytecode engineering that there's an error and you really don't know where it happened. So you can clearly see where the error happened in the stack trace. And if you use a debugger, that works also. I never use it. So I just turn on, I write my own log aspects that seem to me better, because I just say, okay, now I want to log this function here, this time. And that just logs what I want to see. So I never step, next, doesn't work for me. Okay. Any questions? Yes? Okay. The question was, this looks like awesome, what's the catch? So far I didn't find any. So what's the risk? The risk is, for me, seems very small, because Basically, Aspect-J is a modified compiler, and it is possible in the future that the compiler wouldn't be compatible with the current byte Java compilers. But since you can have Aspect-J working on binary weaving, if anything generates bytecode, then Aspect-J can weave into it. So it will continue to work. There might be some changes that don't happen so often to the virtual machine, like new instructions in the bytecode that the compiler might not get, but usually that's really well documented. There's a spec for the virtual machine, so I don't think there's much of a risk there. From our experience, we have much problems with Google releasing new tools for Android compilation, and those are usually the problem. Whenever there's a release, usually something breaks. Thanks, Google. More questions? Yes, Aspect-J is awesome. You should use it.
Imagine that you have a generic exception handling, but you want it to catch every kind of exception that carries. So does it support it? And if it does, can we make exception of the exception? I mean, I want to catch a generic in a generic way, but in some specific cases, I don't want to do it.
Yeah. Okay. So the question is, I might want to have a generic error handler for everything, like we did here, for example. Yeah, sorry. No. Yeah. For example, here I'm just saying catch exception, everything. So you can have generic exception handlers, but you can always have a check here, meaning you call the function you're calling and there's an exception. And inside here, you can have conditionals. So if it's in this class, or if it's after midnight, or whatever, if there's a random number above whatever, then I just throw the exception again. And then it's not caught. Well, it can be there. And there's another thing that I haven't got into, because you must already be mind-blowing. You can have aspects weaving into other aspects. So you could have an aspect that intercepts things in another aspect. I won't go into that because, yeah, it's too much for now, I think. Okay? But it certainly can. There's in the book I have mentioned, there's a few patterns because you're starting to think in a new way. New patterns emerge, and there's a pattern that deals with that kind of situation. Sometimes I have some kinds of exceptions that I want to throw, others I don't. Maybe, for example, if let's suppose caching. Suppose you didn't have any caching and you started to cache things in memory. Okay. So when your application dies, the data dies with it. Okay, it's reasonable. Now suppose you want to start caching in a database. Now you can have another problem because the database can be corrupt, or it can be full, or maybe there's a constraint in the database that throws an exception and your code wasn't ready to deal with that kind of exception. So there's patterns that deal with that. You can catch, for example, you can have your function that does the caching throw exception anyway, but your code wasn't ready to deal with SQL exceptions. So you now have another aspect that catches SQL exceptions and does something with it. So you can certainly do things with that. More questions?
We have like result equals some function that I'll execute in the background. We define an aspect to make it run in the background. Can I, in that aspect, can I have temporary result equals proceed
Okay.
and
Okay.
result then?
Okay. So dealing with the background aspect, there's a problem I didn't mention. You can see that I'm just dealing with backgrounds on functions that return void. There's no return results. Because this can be a problem, I have kind of be aware of that. Because the problem is, yes, theoretically, I could launch everything into a thread, but now I have an assignment. So if I call a function and it's running in the background, and there's an assignment, how do I deal with that? So if you you would have to wait for that code somehow, like a thread join or a thread wait or something like that waits for the result. You would have a problem because your application would be not responding because that variable is still there waiting for the result. So you have to write things a little bit different so it can work this way. But there's a possibility to work. I won't get much into that, but in the Java API there's something called the futures, and that kind of deals with that. Things that run, that return results that you want to pick up later. So there's you can use the standard Java API to that, and fortunately Google didn't cut that from the standard SDK that's available, so you could use that. But you have to be aware of that. So if you don't want your code to block on UI because you're waiting for a result of a background thread, you have to write your code in a different way. So this just shields you from having to write a pile of code to launch things in the background. Okay, more questions? Yeah? Okay. Well, I think that's it. If you have any doubts, there's my email at the beginning. You can throw that questions to there, or there's the site where it's empty right now, but I'll post stuff there and you can always post stuff there. And the presentation will be there after I have some sleep. Yes. So if there's nothing more, thank you for coming. I hope that this leads to thinking another way, because really, after a while, after you get used to this, you don't really see a way back. You just took the red pill and there's no way back, okay? Yeah. Thanks again.